Good morning. Hope you all enjoyed the dinner. It's probably not quite as full as it was, probably due to the dinner. So I'm quite happy about that. All right, the outline of my talk today. I'm going to tell you a little bit about Newmont. I'm going to touch on the jewel of the crown in New South Wales, Cadia, and where next exploration-wise. And I'm just going to tell you a little bit about how we're applying combined technologies to open up some new search spaces. The usual disclaimer, I'll ask you about the third line down, what's in it at the end of the talk. Okay, Newmont is the world's leading gold company and a producer of copper, zinc and silver. Newmont is the only gold producer that is on the S&P 500 index and is widely recognised for its principled environmental, government practices and social practices as well. The company has a world-class portfolio of assets, prospects and talent anchored in the favourable mining jurisdictions of Africa, America and Australia. Newmont is the largest the industry's largest gold resource, and we also have the largest copper resource in the gold industry. The portfolio is focused on Tier 1 gold and copper operations and projects located in the favourable mining districts. There are 4 features of this portfolio. Firstly, it contains 10 Tier 1 operations, representing more than half of the world's Tier 1 gold mines. Secondly, we have 3 emerging operations and an opportunity to create a Tier 1 district in British Columbia, an area which Newmont believes will be working well into the next century, or for at least a century. Thirdly, we've got unmatched organic pipeline with 6 large-scale copper projects in that pipeline. And underpinning all of that, of course, is the previously mentioned robust foundations of reserves and resources. As one of Newmont's key value drivers, exploration activity is focused on the 17 operations globally, with 80% of the spend directed towards near-mine extensions and brownfield expenditure. Newmont also has a strong supporting greenfields portfolio, with the remaining 20% representing greenfields expenditure, earmarked for advancing greenfields projects towards investment decisions and then supporting future new discoveries, which is a bit I'm more excited about. We're well supported in exploration, and being in a region that is blessed with amazing assets of Tanami, Boddington and Cadia, that does help. Cadia, wow. Having looked over the fence for many years and now to be amongst it, it's special. I'm not going to pretend to be an expert. More than half of this room has seen a lot more of Cadia than me. However, as a quick recap, Cadia came to Newcrest through BHP Gold in the early 90s, and Newcrest worked diligently to develop and explore that area to be what it is today. Comprising production mining is from an underground panel cave mining at Cadia East with underground crushing and a conveyor that brings ore to the surface, and the processing plant which produces copper and gold concentrate, gold doré and molybdenum concentrates. Cadia proudly has a workforce of more than 1,500 employees, with around 85% residing locally. And it contributes more than $1 billion to the regional turnover each year. All right, let's get into the geology bit. Porphyry-related mineralisation at Cadia Valley is located in the Macquarie Arc, shown in green. And this Ordovician Silurian volcanic arc once sat distal to the main cratonic margin of Australia, and it collided with Australia at the time of peak porphyry mineralisation. It's important to note that the majority of the porphyry-related mineralisation in the Macquarie Arc is not related to subduction, but rather their emplacement is largely post-orogenic. This timing is important in that the causative magmatic and hydrothermal fluids are located along deep crustal scale features, including the so-called Lachlan transfer zone. This deep crustal architecture helped localise mantle-derived melts that resulted in the higher grade gold and porphyry deposits that we see in the Cadia Valley cluster. The geology of Cadia Valley has been well documented, but here we should emphasise the size of the system. Over 55 million ounces of gold is located in and around the zoned intrusive complex, where a cluster of 4 porphyry deposits are localised in 7 kilometres of the Earth's crust. It's quite amazing, really. The bulk of mineralisation is associated with the multi-phase dioritic and monzonite stocks and dikes. The timing of the mineralisation across the districts has Ridgeway deposit in the northeast being the oldest at approximately 440, whereas the porphyry-related mineralisation at Cadia East is a smidgen younger at 438. Post-mineralogical orogenic events have really exhumed, deformed and buried the mineralisation, with this deformation manifesting itself as thrust displacements, the most obvious being along the Cadia-Angulong fault. Shortening across the district has resulted in deformation and backward tilting of the Ridgeway deposit, whereas the Cadia East deposit remains largely upright and intact. The history of the exploration around Cadia Valley is well known in this room, from the early discovery of outcropping mineralisation around Cadia Hill to the systematic step-out drilling, which led to the discovery of Cadia East, and then systematic deep drilling, leading to the discovery of Ridgeway. Ridgeway mineralisation was concealed by 50 metres of tertiary basalt and a further 500 metres of barren green rock. Over time, the experience gained at Cadia has been one of deep drilling the lateral and vertical extents of these single porphyry centres. Drilling tested the deposits down to a vertical depth of about 1.5 kilometres. Extraction of these deposits has been by highly effective block cave underground techniques. Unlike the growth of the exploration understanding, this has evolved from sub-level caves to block caves to what we're using now, the larger draw height panel caves. And Newmont continues to expand the exploration of this, the exploitation of this block caving expertise into its wider portfolio in Australia and across the district other jurisdictions. Just a view of the rocks. We've probably seen this slide before, but it's always nice to remind ourselves of the contrasting mineralisation styles that occur in the Cadia Valley, with obviously the earliest 1900 mining centred on the gold-bearing magnetite skarn. But it will be the recognition of coexisting skarns and porphyry-related mineralisation that really drove the large-scale development of Cadia Hill deposit. Since its discovery in the 1990s, this alkalic porphyry-related mineralisation is unusually higher grade in copper and gold. From the pegmatite mineralisation in Cadia Quarry to the larger volume porphyry mineralisation at Cadia East to the higher grade small footprint at Ridgeway, all the Cadia Valley deposits are unusually higher grade compared to the bulk of the world's copper-gold deposits. A single intercept at Ridgeway can be as much as 30 grams per tonne in primary porphyry mineralisation. Newmont has two significant deposits with evidence of this higher grade in Ridgeway and Red Chris. For a long time, it's been shown that the Ridgeway has a very subtle footprint. The column itself is only 600 metres wide by 300 metres across. The edges of the system are characterised by steep and sharp geochemical and alteration gradients. Shown here is a subtle reddening of the ground mass and felspar with intense sodic alteration and a low geochemical expression. The magnetite alteration subtly coarsens as you come closer to the porphyry deposit. Extensive drilling across the Cadia Valley has delineated the large-scale porphyry centres. However, we believe there's a residual upside remains in focused exploration for the smaller footprint systems that have the potential to deliver small tonnage, higher value metal volumes. Newmont has renewed exploration drilling for these smaller footprint columns. What you see here is a grade cutoff of around 0.75 gold equivalent on the drill traces, which pulls out areas where higher grade may still be open. We are focused on immediate drilling around these higher grade volumes of mineralisation, primarily around the bottom of Ridgeway, along the edges of the zone central intrusive complex, and deep extensions to Cadia East, and also step-out drilling in the Warragong area. What you see here is some of the core that we've been drilling of late. We began drilling the deeper parts of Ridgeway system. This is the first drilling at depth and outside the known resource since 2009. We're excited by the observed density of quartz stockwork, the visible veinlets and dissemination of bornite and chalcopyrite throughout. Very encouraging. The undercover search space. So as well as looking for these high-grade sweeteners, the other area of focus is undercover. Understanding the importance of cover to conceal the giant porphyry deposits, we can look at the pre-mining geology. We've compiled the observed alteration zones that highlight juxtaposed zones of porphyry-related stockwork that once outcropped at Mars Forest, now the Cadia Hill deposit, and a zone of pyrite albertoline alteration well above Cadia East. You can see the alteration cells marked on the map here, and also the yellow circle which marks out the area of where Cadia East is. This map also highlights the full extent of this Silurian cover across the deposit, shown in light blue in the map. The Cadia East deposit represents a significant targeting example of undercover search for concealed deposits both in the Mac Arc here and across Australia. It's important to remind ourselves that 70% of it was undercover, under 20 to 200 metres of Silurian cover, which is shown on the left. It's not very obvious, but just under the number one, where there is an unconformity on the edge of the pit, well, obviously with Cadia Hill, my primary body being underneath that. These younger Silurian faults can be used to predict the underlying Ordovician fault architecture. And with fluid flow along these long-lived faults, likely to have pumped some metals from the underlying Ordovician porphyry deposit through the Silurian sandstones. So in support of Newmont's commitment to organic growth, we're also somewhat unique given the standing commitment to R&D in the exploration technology space. We've known that geophysics is important for underground research for a long time, and Newmont has a long history with an early development of IP in the 1940s. In geochemistry, this began with BLEG, which was a stream sediment sampling technique, offering very good repeatability compared to some of the lab techniques at the time. And while we punctuate our timeline with dates and tools and acronyms, really it's been a continuous journey of commitment to understanding, testing, deployment, field testing, does it work, feedback from the geologists. All this has allowed for a better integrated approach in which geologists, geophysicists and geochemists are working together to apply the most appropriate technologies for the problem they're trying to solve. So I'll just touch on DSG, deep sensing geochemistry, as we call it. There's a lot of research about the methods and mechanics of metal transport through blind and post-mineral cover. And one collaborative study by Amara in the 2010s led to a focus on the mechanisms and orientations and experimental replications, and showed that the migration of the elements, including gold, the signals are very subtle. So whilst labs have changed their reagent purity and instrumentation and pushing the detection limits lower and lower, the field sampling had not really seen the same level of innovation. So we saw this as an opportunity to develop a cradle-to-grave concept that had worked for us so well for BLEG by applying the knowledge around targeted representative sampling in the field to present a cleaner, more repeatable sample. The figure on the left shows the figure on the left shows a conventional sampling approach where the subtle signals from depth will be swamped between the noise, as opposed to the DSG concept, trying to minimise the background noise and specifically target more mobile contributions from depth. This was leveraging the same theory and in-house lab as BLEG, targeting the bulk fine-grain fractions. Initial test work in Nevada and Australia between 2013 and 2015 generated encouragement. And by 2015, this became the new pillar, geochemical pillar for district and regional plays throughout the portfolio. TMG, terrain mapping geochemistry, was developed for the regional reconnaissance in areas where BLEG could not be deployed due to lack of drainage or areas of deep weathered terrain, where regolith formation had obscured the ability to map the geology. By leveraging the same laboratory processes as DSG and just adjusting the survey plans to be broad reconnaissance grid, TMG method focuses on characterising the regolith, lithology and structure, mapping features that can then be integrated with the geophysical data sets and generate new geological frameworks. TMG has a value as a targeting tool, as you can see from the figures on the right, where the 2x1 spacing in the Tasmanides Desert, which was then subsequently infilled with DSG spacing. Personally, I'm more interested in the ability to pull out the geochemical characters into areas of limited surface geology and to assist with the mapping. Metal values. The other area of innovation is around core scanning, and Newmont have got a commitment to this. The metal values, and this can provide metal values at the time of drilling for rapid identification of targets and target volumes, allowing for improved drill hole planning. Real-time clustering of that data can help to give us some insights into logging some of the subtle geology. There are potential applications for machine learning in other areas, in geotechnical models and in geometallurgical modelling. What you see here is these are 2 slides from Redcliffe, and at Redcliffe there's over 200 kilometres of core has been scanned. And the comparison on the top is from TrueScan, and the one on the bottom is from the assays. So we're seeing some of that replication. So as the 2 teams merge into one, we are looking to apply technical expertise together, leveraging combined Newmont's exploration experience and technologies to focus on world-class high-grade gold and copper deposits. As you see, we've got a complementary toolbox of technological solutions. We're looking to expand the search base by applying these appropriately to mining and exploration activities. We've got a continued appetite for drill-ready gold copper projects where we can leverage our technologies to uncover Tier 1 systems. With that, I'd like to thank my colleagues who have assisted with this compilation, Anthony Harris and Simon Marshall. Also a call out to the New South Wales team, many of whom are in the audience, so direct any difficult questions to them. And finally, thanks to Mines and Wines for providing me with the opportunity to present.